Hello all, today we are solving LeetCode problem number 1320, minimum distance to type a word using two fingers. So let us read out the problem. So basically we are given this particular layout as a keyboard, which is shown above the XY plane, where each English uppercase letter is located at some coordinate actually. So we start from 00, we have A, and 01 we have B, and it goes on. For example, letter A is located at 00 and B is 01 and P is 23. So we have from A to Z. So the distance between the coordinates can be calculated. So if we have to calculate the distance between two coordinates, you have to consider these two as the coordinates, and the distance is absolute difference between x1 minus x2 added with y1 minus y2. So note that initial position of your two fingers are considered to be free, so do not count towards your total distance. So when we start, the initial distance will be 0. That is what they exactly mean here. Also, your two fingers do not have to start at the first letter or first two letters. So with this observation, we can say that we can either start with finger 1 or finger 2. So basically we will write down the observation. So observation is we have two fingers, so F1 and F2. Also we have distance given, which is x1 minus x2 absolute value added with y1 minus y2 absolute value. So now what do we need to do is we need to find uh, the total minimum distance actually. So return the minimum total distance to type such strings only using two fingers. So what exactly we need is the minimum distance. So based on this question, so if a given word is CAKE, we have to look up into this particular keyboard. So we have C here, so this should be the first one, and second one to type, and KE third and fourth, right? So we can use finger 1 to type all these four letters. So finger 1 to type all four, and finger 2 also to type all four. Also we can use both finger 1 and finger 2 combination to type all four, right? So this can be divided into, like little bit. I mean, we can divide this into multiple combination, because you may use three letters finger 1 and one letter finger 2, or to divide among equally to 2, or you can have 1 and 3. So it based on the decisions which we take, right? So one thing to observe here is we need minimum total distance, and we have this particular sub problem and this particular sub problem. So based on this particular sub problem, it is based on choosing the decision and choosing the minimum distance from that particular thing. So we solve sub problems and derive answer, so which is nothing but dynamic programming. So that is what exactly we are going to use to solve this particular problem. So looking at this, we have the problem of choosing the fingers to type. So we will start with finger 1. Okay, so we will start with the initial position, which can be the -1, because you cannot have it as 00 because that indicates A. So now from this you can use finger 1 and finger 2, right, to type C. Okay, and to type the next word cake, you have again four combination. You can use finger 1 only, or finger 1 followed by finger 2, or finger 2 followed by finger 1, and finger 2 finger 2. So for C you have four possible combination, and further you will divide this problem into multiple sub problem, and again from here you have one more division, because this level deals with letter K, C, A, K, and the last level deals with E. So you have many possible combination from it, and you will choose the minimum distance. So you will use, when you choose this particular decision, when you, for example, when you choose from finger 1 to finger 1, if you choose this particular decision, you will calculate the minimum distance. So how do we calculate? So we know that we have C and A. So C, you know how to find the coordinates, right? So in order to find the coordinates, what we can do is, looking at this, we have 1 2 3 4 5 6, right? So 6 columns we have, and 1 2 3 4 5 rows we have. So using the 6 columns only, we can locate the index position. So for this particular position, the row which is I is equal to 0, and for locating C, and J is equal to 0 1 2, so this is 2, by looking into this particular grid. So how do we find it? So for locating this particular row, you can use is 6 divided by the given value actually. So you have A, you have C. So how do you find the ASCII value of it? You have to use the ASCII function to find it. So what you can do is, you can use ASCII function using odd function. So ASCII value of C minus ASCII value of A. So this will give a index position, so which is nothing but this is 99 minus 99 minus 97. Okay, I think that's a smaller value, but anyway, this gives actually this gives 2, so which is nothing but 0 1 2. So you get um, you get the 2 as the value which you will divide, and you get if you round off this particular value, you get 0, so which indicates row. To locate the column, we have to do the same thing, but we have to modulo with 6. So to modulo the value you found using this ASCII, modulo with 6 gives 2. So in this way you can find I and J. So from this you get ij, which is 0 2, and for A it is 0 0, and the distance is 2 for finger 1 and finger 2. I mean finger 1 and finger 1 as the next decision, right? So this is how we repeat the problem and solve this particular problem. So let us do a dry run and we can solve it, so we will have a better understanding. With that help, we can go ahead and code this up, right? So let me clear this. Yeah, so now we are standing at this position, which is 0, and if we are choosing finger 1 as the next decision, so we type this, which is 0 2 and 0 0. Now the distance is 2, right? And see, A is done, and K. So again, if you're using finger 1, what happens is from A to K, so from this to this is 2, and from A to K, 1 2 3 4 5. So you have 5 as the distance, so this will be 5. No, 1 2 3 4 5 6, so this is 6 actually. So the distance is 6. So you have 8 here to type K, and KE, this has 1, so which results in 9. So which obviously is not a good decision, because we are using only finger 1 finger 1 finger 1 and finger 1. So this is the result of it. And what if we consider the optimal solution, which is nothing but we start with finger 1 C, and we move to A finger 1, and using finger 2 we start with K, which means it will be considered as 0. So this goes out, and what happens is from K to E you have 1. So 2 plus 3 results in 2 plus 1 results in 3. So which is exactly the output which we are getting it from here. So what exactly they have mentioned in this explanation as well. So let me draw a decision tree based on this. So we start with -1, -1, and we have finger 1 and finger 2. So let us expand this only. So finger 1 and finger 2, then finger 1, finger 2. So we can expand this further, but this is the optimal solution. So we choose C A, or yeah, C A K E. So this results in 3, and this is the minimum among all the possible solution. So this is the path which we are choosing to derive that particular solution. So this is the idea. So we will be doing this memoization technique to implement this particular solution. So with this idea, let us go ahead and code this up. So we need a function which will calculate the distance, right? So let us define the function. So distance which will get the input, which is A and B, right? And let me let us do that later. So now we will have DFS, which will take in 3 inputs, which is the index, then followed by the finger 1 and finger 2. So we contain that we have the decision stored for stored in this finger 1 and finger 2 variable. So the base case is, what happens is when the index is equal to length of word, we return 0. So this is the base case, and now we will have to find the current letter. So using that we will be getting the current position, right? So current is equal to odd of word of index. So and this is separated by odd of A. So now you get the current value, and now you will have the decision. So finger 1 is equal to now distance, where we pass in the finger 1 and the current value, right? So this is added with DFS, where we pass in index plus 1, because we are incrementing and moving to the next position. So index plus 1, and current will be the finger 1, so which will have the index position, the value, and finger 2. So we will copy the same, and there is slight difference. So finger 2 will be calculated with the help of this, will become current. This will become F2, and this will be current. Then you have the same index incremented by 1, and this becomes F1, and this will be current. So that's it, and now you have the decision handy. So now you have to find the minimum value, and so you will return minimum among these two, finger 1 and finger 2. So these are the two major decisions from which the branch grows. So ultimately this will choose the minimum value branch actually. So you will have only 2, which is starting with finger 1 and finger 2. So you will choose any minimum among both these branches, right? So now to call it, what we have to do is we have to return calling DFS, and passing the index position 0, because ultimately this is the base case. So in this place it will be returned as 0, and we will pass in 26 and 26. So this is the thing, I mean the function call. And for this particular distance, so we have to calculate, I mean we have to say that if a is equal to 26, if it is 26 or b is also 26, we have to return 0. If because yeah, so now we will return 0, and then we will calculate the absolute value of x coordinate and y coordinate. So in the explanation I have mentioned how do we find the x coordinate and y coordinate by using this particular division and rounding off the division value with modulo, right? So we will do that. So if a is equal to 26, 6, return 0, and we will return absolute value of now a divided by 6. So this added with absolute value of a modulo 6 and subtracted by b modulo 6. Yes, and for memorization we did not use any map, so we will be using LRU cache. So and we'll have none. Yep, and that is it. Let us run it. This should be equal to not assigning operator. Okay. Oh, okay, so it's, oops, there is a typo here. CHE cache. So what is type error? Exactly take one argument. Oops, there is a comma. Yeah, now I guess this should work fine. Yeah, let us submit it, and there you go. Thank you.